Congratulations, you have almost finished your first year of engineering studies at McMaster University. Very soon, the engineering faculty will ask you to specify which department you would like to continue your studies in. Normally at this time, you would have the opportunity to go to info nights for all of the departments that you're considering. Unfortunately, due to the COVID-19 pandemic, all of these info nights have been moved online. Over the course of this video, I hope to answer any questions that you may have about mechanical engineering and that I am equipped to answer as an upper year undergraduate mechanical engineering student. You can check out the description of this video to see all the questions that will be discussed, along with a timestamp of specifically when that question comes up. If any question that you have is not among that list, you are more than welcome to email me at awasem@mcmaster.ca or communicate on Microsoft Teams on the Mech Info Night channel. And without further ado, let's get started. What is mechanical engineering? Well, the definition that I stole off the university's website is that mechanical engineering is the application of principles of physics for design, analysis, manufacturing, and maintenance of mechanical systems. Mechanical engineering is a very broad discipline of engineering that covers plenty of different industries. People like to compartmentalize the field in many ways. Personally, I like to divide mechanical engineering into three subfields, and they are HVAC, manufacturing, and mechanical design. So let's take a closer look at these three subfields. HVAC stands for heating, ventilation, and air conditioning. HVAC engineers may be tasked with designing heating and cooling systems. That's generally their job. They're the people that need to install, select, maintain, and repair HVAC equipment. A common task for an HVAC engineer would be maybe they have to design a central air conditioning system for an apartment building. HVAC engineers rely on the knowledge that they learned in courses like thermodynamics, fluid mechanics, heat transfer, thermofluids, and many, many more courses offered by the mechanical engineering department here at McMaster. One of today's hot topics is how we can reduce our carbon footprint, and HVAC engineers are on the front lines of solving this problem. McMaster's own Dr. James Cotton is researching integrated energy systems as part of Ontario's 2030 climate change plan. His proposals attempt to harvest more waste heat and reduce Ontario's greenhouse gas emissions. You can actually read more about Dr. Cotton's research on the McMaster website, and I'll put a link in the description too. But if this is something that you're interested in, this field, I would highly recommend doing more research on how HVAC might be the right path forwards for you, and the courses that McMaster offers to help you supplement your understanding of this field. Now, the next subfield that we'll be talking about is manufacturing. Manufacturing engineering by itself, to be honest, is a pretty broad field. It generally refers to the development of processes that turn raw materials into industrial products. Manufacturing engineers are the folks that are needed in plants and factories in order to optimize the production of millions of parts that are produced per day in these facilities. In Ontario, many manufacturing engineers are employed in the automotive industry. In fact, I believe Ontario's main export is automobiles, so that's why we need so many manufacturing engineers to ensure that the production of these machines is made as efficiently and as cost-effective as possible. There is some exciting research happening in manufacturing as well, with concepts like digital manufacturing, IoT, Industry 4.0, smart systems, and myself, I'm actually really passionate about this stuff, so I'm going to take a few minutes just to talk about some cool things happening in manufacturing to perhaps pique your interest. So the main goal with research and manufacturing today, the main thing that everyone is trying to build towards is making fully automated end-to-end manufacturing systems. Imagine a factory that is fully autonomous. There is a concept known as lights out manufacturing, and the idea is having a factory or manufacturing facility that is fully autonomous. You can turn the lights off because there are no humans needed in the facility. It is all robots that are managing the entire manufacturing, and these robots are communicating with each other using IoT to ensure that no humans are needed. Humans need not apply. Imagine essentially Tesla's Gigafactory, but taken to the next level. And this would allow us to manufacture 24/7. We don't need workers to come in for 8-hour shifts. It just never stops continuous manufacturing. Another cool idea is flexible manufacturing. As of right now, it is generally more difficult to design the process to manufacture something as opposed to the part actually being manufactured. And that's because it takes millions of dollars and months to retool a factory to manufacture a new part. And because this is so tedious, it essentially discourages companies and factories from being innovative because it is so cumbersome to switch your factory to manufacture something in a different way. And that's not good. It's not good if innovation is not easy. And so the idea of a flexible manufacturing system is a system that allows factories to easily switch between manufacturing different parts of different quantities. One very, very basic example of a flexible manufacturing system is a 3D printer, because a 3D printer can produce a wide variety of parts of varying geometry, unlike, let's say, an injection mold that can only produce one type of part, albeit very efficiently. And so if you had a massive print farm, you could essentially mass produce parts of different types instantly. All you would have to do to change the part that you're manufacturing is swap out the file that you send to your 3D printer. And that's why it took Joseph Prusa only one day to switch from 3D printing printer parts to 3D printing face masks for the COVID-19 pandemic. He made that switch in one day. Think about how long it would take GM, Toyota, or some other auto plant in Ontario to make that switch. Although, to be fair, there are massive issues at the moment with 3D printing. The quality and the print time make it not feasible for mass production, at the moment at least, but maybe you can solve this problem. Although, to be fair, even if we did solve this problem, manufacturing is so archaic and resistant to change that it would take decades to really implement anything. And the last subfield that we'll be talking about is mechanical design. Mechanical design, as you can probably infer, is just the application of mechanics in order to design physical, tangible stuff. Mechanical designers have to do a lot of CAD. I emphasize a lot of CAD, whether it is the designing of technical drawings for parts that need to be machined, or just the modeling of some parts or assemblies, or perhaps to run simulations on their CAD to ensure that their math is correct and the assemblies perform as needed. For example, a mechanical designer may be asked to design the bumper of a car, and so they would have to first CAD the bumper, and then they would have to run a simulation on the bumper with, let's say, FEA to ensure the bumper crumples correctly under the load or impulse. Next question. What specializations are offered by the mechanical engineering department? So, in conjunction with the last question, the mechanical engineering department offers 3 specialties that students can take, and they are thermofluids and energy, which you can think of as being the HVAC substream, manufacturing, and mechanics and design. Now, students do not make this decision until their second last year, so you have tons of time to think about your specialization. In addition, you can also join one of the many 5-year programs offered by MAC, and they are Management, Society, and iBiomed. I am in none of these 5-year programs, so I cannot say much about them, but I do believe mechanical has the second largest cohort of iBiomed students, after ECE. I imagine you would have the greatest if it wasn't for how elect and comp is combined. But yeah, all of my iBiomed management and society friends like the programs that they're in, so I'm sure they're exciting things that you may want to look into. Although something to keep in mind is that these are 5-year programs. So if in addition to the program, you also wanted to do a year for co-op, you're looking at 6 years in university. So think about if that's something you want to commit to, your next 6 years in school. I don't know if I can make that commitment myself. I don't know if I'm that academically inclined. But perhaps that's the right thing for you. So definitely think about that. What courses do mechanical engineers take? So I would highly recommend anyone who is at all interested in mechanical engineering check out the academic calendar and course listing for the department. So you can check out the academic calendar for mechanical engineering by clicking on this link right here. And this shows the general calendar for standard mechanical engineering stream. So that's without society or management or iBiomed. And here are the courses taken in second year, third, and fourth. As you can see, fourth is not as defined because you get to take plenty of technical and complementary electives. I would also check out the course listing website. And on here, you can see a description and course outline for each course. So for example, 4B03, product development, I'm taking that right now. I can check out the outline and see how the course is marked, where the grades come from. I would highly recommend look at the relevant course listing and academic calendar for the departments you're interested in. Now, something you'll notice if you do check out the academic calendar is that mechanical engineering students do not have any customization options for the first few years. Mechanical engineering students do not take any complementary or technical electives until fourth year. Mechanical engineering students also share a lot of courses with other departments because, of course, our field is so broad. We have courses with Tron, with Metals, with Civil, with tons of other students, fortunately. Where do mechanical engineering students work on campus? So as a mechanical engineering student, you will get keycard access to a couple of rooms on campus that should be of great use to you. There's the Mechanical Engineering Lounge located on the second floor of JHE. That's a popular spot to work on projects and get work done and just unwind. And there is also the Mech Eng Computer Lab located in ABB C202. That's the new building located right adjacent to Thode. And the great thing about this lab is the computers not only have Autodesk Inventor and ANSYS and other useful software, but they have the RAM, the hardware, to actually run the software applications. Shockingly, but fortunately, which makes this a great place to do CAD and to get projects done and such. And of course, mechanical engineers, like all other engineering students, hang out in Thode, the machine shops on campus. In fact, there is a Mech Eng specific machine shop located on the second floor of JHE, where you can work on projects and where you will also have some courses in second, third, and fourth semester. How do I get a co-op? You will notice that this question is in all caps with an exclamation mark because it is a very popular question. I would say the most popular question, understandably. Before you can go on a co-op term, you have to make sure to get the course Eng1 EEO done. That is a no-credit, primarily online course that you have to get done in order to be eligible to go on a co-op term. It's more of just a liability thing, to be honest. Now, co-op opportunities are listed on the job board Oscar Plus. You can check out that job board to see all of the co-ops that have been scouted out through the Engineering Career and Co-op Services Office. In addition to that, ECCS will host weekly industry nights on campus where students can meet with and network many companies, potential employers, and hopefully land an interview. Some companies that have their own industry night include Tesla, Google, IBM, Tabasco, and many, many more. Now, some tips that I hope you keep in mind is that for every single job listing on Oscar Plus, there are plenty of students applying for that job at just Mac alone, in addition to all the other students from all the other engineering schools in Ontario, Canada, the world. So it is competitive, unfortunately, and you have to find a way to differentiate yourself. You have to make sure to highlight your skills, your unique skills, during the application process. And I guarantee you that you have some unique skills, whether maybe it's a high GPA that you can include on your resume, or perhaps you have a network. You have some friends or family who knows someone, who knows someone else, who knows someone else that is looking for a co-op intern. So make sure to ask around, because that is definitely the easiest way to get a co-op job. In addition, maybe what will make you a great hire is all of the practical experience that you've garnered in your participation in engineering extracurriculars, like the Baja team, the solar car team, etc. So make sure to talk about that during the application process if you have any experience on extracurricular teams. If you don't have any experience there, why not join an extracurricular team? They are always looking for new students to come in as part of the recruitment process. Now, in my opinion, the best way to get a co-op job is to have a portfolio of side projects that you can show during interviews. If you have no technical projects at the moment, I would highly, highly recommend starting some cool projects that show that not only do you get good grades, but you're creative, you can make cool stuff, and you can actually get things done. I know this quarantine is really frustrating. It's frustrating for me too, like it is for all the other students. But maybe now is a great time to actually start that cool project you've always wanted to make. Whether it's some robotic arm or some cool app, now is a great time to show that you can actually make things as part of your engineering experience. The last thing that I would ask you to keep in mind is that co-op jobs are way easier to get during the fall and winter semesters as opposed to spring and summer. There are way less students competing for jobs at that time, and it is much easier to land a prestigious job during that period. Do I get to design and build things as a mechanical engineering student, or will I just be studying all the time? You absolutely get to build things in mechanical engineering. One of the things that I'm very proud of for the department is their understanding that experiential learning is vital to a student's development. And that's why there are so many project-based courses in mechanical engineering, whether it's the mandatory courses like 2A03, 2CO4, 3E05, or the technical electives you can take to give you more chances to make cool stuff. But something I would ask you to keep in mind is don't wait for some course as an excuse to build something. Now is a great time to pursue a cool project for something you've always wanted to make. And if you don't have the skills just yet you feel to make a cool project, why not join one of the many extracurricular engineering teams on campus like Baja, EcoCar, Trotsky that will give you the skills needed to make cool stuff. And in addition to that, a network of great students who also have a passion for similar topics as you do. I would highly, highly, highly recommend to pursue some cool projects that show you're creative, you can make cool things, and that you are a great engineer. Does studying mechanical engineering mean that I have to work as a mechanical engineer? Will this choice that I make in the next month define the rest of my life? No, not at all. You will be shocked by how many engineers are working in a different engineering discipline than their field of study. It is so common for engineers to switch over from different fields than they studied back in university. In fact, plenty of engineering undergraduates do not even pursue a career in engineering. They go on for some totally different career path. The smartest engineering students that I knew in undergrad ended up graduating and going on to med school to become doctors. So in no way is your future ever set in stone. I can tell you from my personal experience that even though I have studied mechanical engineering for these past few years, most of my co-ops have been software based. My first co-op was with Dr. Doyle, and it was on campus as one of the on-campus summer jobs with Mech work, and I was writing software for one of his courses. And then I was an IAI for Eng1CO3, which I guess is more of a mech-based role, but my main goal there is predominantly not really expanding my mech knowledge, but I was hoping to become a professor at the time, and I thought that was a good route into academia. And then my next co-op was as a controls intern at an automation company. So I was programming robots to move correctly and not crash into each other, hopefully. So a lot of PLC programming and that sort. And then my co-op for this summer is officially, my title is a robotics research intern, but essentially I'll be doing a lot of JavaScript and other programming this summer. So in no way at all is your future ever set in stone. Always make sure just to pursue your passions and what you're genuinely interested in. How hard is mechanical engineering? How hard is it to study for mechanical engineering courses, and how hard is it to pass mechanical engineering courses? It will be incredibly difficult to study for mechanical engineering if you do not like mechanical engineering. It is so tough and soul-crushing to do work for a course that you just don't care about. So please make sure to not put yourself in that situation. Please make sure to base your academic plan on your next few years based on your interests and your passions. A strong network of friends and colleagues also makes it significantly easier to succeed academically in whatever path you take going forwards. And if you don't have that network just yet, a great way to foster a network is by joining some engineering clubs and other extracurricular activities like Baja, Red Suits, Musical, in order to meet more engineering students and just make your time at Mac that much more fun. Why did I choose mechanical engineering? And there's only one answer here. It's obviously, I know I'm kidding, but of course, how is making Iron Man suits not cool and not a dream every mechanical engineer has? But my main motivation was at the time that I was finishing up first year, which was back in April of 2017, so long time ago. I knew that I had my main interest in robotics, and I wanted to learn more about Industry 4.0. And I also knew that I didn't want to be in a situation where I was writing that many exams. I wanted to mainly be actually making stuff, getting hands-on experience. So at the time, I was debating between software, mechatronics, and mechanical, and I thought Tron was the obvious choice because I was so into robotics. But then I noticed how Tron was mainly theory-based. There weren't that many chances to actually make things. It was just mainly exams. So I felt like if I chose that path, I'd be mainly studying all the time and not actually getting to build stuff, which is what I was hoping to predominantly do in school. So I ended up choosing mechanical engineering as my first choice because I felt this stream gave students the most chance to actually make things, the most experiential opportunities. Tips for incoming mechanical engineering students. So I'd recommend taking Math 2Z03 and Math 2ZZ3 during the spring and summer semesters. It is so much more tedious to get these courses done during the school year. So if you haven't landed a co-op yet, I would definitely recommend spending the summer trying to take those courses. And even if you do get a co-op, the courses will be online this summer, so it should be that much easier to do co-op and courses at the same time. That's what I did, so it is survivable, so I definitely recommend it if possible. I would also try to highlight that it is so much easier to get through engineering if you have a good network of friends to rely on. So really make sure to cultivate that because otherwise going through engineering just won't be fun. And keep in mind that upper year students want you to succeed. They want you to have a good time. So always make sure to ask them, if possible, for old notes, midterms, etc. If you see me in the hallway next year, by all means ask me for any resources that I'll have, and I'll make sure to do my best to pass them on. And finally, and this is the most important tip I can give, school goes by so fast, so please try to enjoy your time here and have fun. Thanks so much for listening to this presentation. I hope it has helped you make your choice for next year, and please make sure to take care and stay safe for the next few months. Alright, bye!